Okay, so continuing on strategies to solve limits, we're going to work with the second strategy now, factoring. And factoring usually works when you have a rational function with polynomials in the numerator and denominator, and it usually direct substitution yields an indeterminate form 0 over 0. And I'll go over this this second point in more detail in an example. So, for example, let's say that we got the limit as x approaches 1. This is actually the same limit that that we used for the last example in direct substitution over x minus 1. So as you can see, it's a rational function with polynomials in the numerator and the denominator. And if we directly substitute 1 into this function, we'll get a form of 0 over 0. Okay, so if we try to plug in 1 squared minus 1 is 0 in the numerator, and then 1 minus 1 is 0 in the denominator. And then 0 over 0, we can't, that's undefined. So we can't just use direct substitution. So what we can do here is we can do the limit as x approaches 1. We could factor x squared minus 1, so that would factor, that's a difference of squares, that would factor into x plus 1, x minus 1, over x minus 1, and then the x minus 1s will cancel out, and we'll be left with the limit as x approaches 1 of x plus 1. And then we could just substitute 1 for x, so it will equal 2. Okay, let's go over another example. So let's say we got the limit as x approaches 3 of x squared plus 3x minus 18 over x minus 3. So if we plug in 3 for the numerator, we'll get 0, but if we plug in 3 for the denominator, we'll also get 0. So we'll get an indeterminate form of 0 over 0, so we can't just use direct substitution, but we can factor the numerator. So x squared plus 3x minus 18, that factors into x plus 6, x minus 3, over x minus 3. The x minus 3's cancel out, so we'll be left with the limit as x goes to 3 of x plus 6, and that will just equal 9 when we plug in 3 for x.